The FACT-RCF Building Products Limited (FRBL) is a joint venture of the Fertilizers and Chemicals Travancore Limited (FACT) Kochi and Rashtriya Chemicals and Fertilizers Limited (RCF) Mumbai, both public sector undertakings under the Department of Fertilizers, Government of India. The state-of-the-art plant is set up at Kochi with Australian technology for manufacturing gypsum-based building products, glass fibre reinforced gypsum wall panels and wall plaster.
What you see here is a 2-storied, 4-flat apartment building constructed recently. From the outside, it looks like any other conventional building. So, what's special about this? It has been built much faster than conventional buildings. In just 1 month, it demonstrates the use of a green alternative technology, making use of industrial waste gypsum and glass fibers in the hollow panels called GFRG panels. This building, which does not need any plastering, uses much less cement, sand, steel and water than conventional buildings. In summary, the construction is rapid, cost-effective and green. What you see here is the stock of waste gypsum, 7 million tons of it, with an addition of 2,000 tons every day, piled up into a hill awaiting disposal. It is this waste product of the fertilizer industry, reprocessed by calcining to make gypsum plaster, that forms the raw material for the GFRG panel. The panels manufactured at RCF Mumbai and FACT Kochi. The panels are cast in 3 stages on a special table by pouring a paste of calcined gypsum and other chemical additives. Glass fibers are spread evenly onto the mix by means of a screeding and rolling process. Next, special aluminium plugs are inserted on top of the finished first layer with 20 mm gaps in between to form the hollow cavities in the panel. Now, the second pouring of the mix is done along with cut glass fibers with tamping to form the ribs of the hollow panel. In the third stage, the process of the first stage is repeated to complete the top layer of the panel. After setting, which takes 25 minutes, the plugs are withdrawn and the casting table is rotated, and in its vertical position, the panel is taken out for drying by means of a special forklift. The drying of the panels is done in a dryer chamber in which hot air is circulated to dry the panel evenly for 90 minutes. After drying, the panels are cut using a computer-aided and automated process tailor-made to the specified requirements for any building project. It is important that all this information is carefully planned in advance and furnished at the plant site by means of cutting drawings to be furnished by the architect or engineer. The cut panels are then loaded onto trucks, keeping them in a vertical position using stillages so as to avoid any damage during transportation. We now see these trucks arriving at the construction site. On the first day of the superstructure construction, the wall panels are erected with the help of a crane. A special locking system is used to grip the ribs of the panel on top, enabling easy lifting without any damage to the panel. The panels are hoisted vertically and positioned in place over the starter bars jutting out from the plinth beam. Then, appropriate reinforcement bars are inserted as per the design into the cavities. In this 2-storied building, every third cavity is required to be filled with concrete and reinforced with a 10 mm bar. Other cavities can be filled with any inert material such as quarry dust mixed with 5% cement and water. The vertical steel bars are tied to the starter bars, and the verticality of the panel is ensured by using the plumb bob. Grooves are cut into the edges of the panel to facilitate integral bonding with adjoining panels. It is mandatory that all joints between connecting panels are filled with concrete and suitably reinforced with steel. The entire ground floor wall panel erection is completed in 4 days. The door and window frames are then fixed in position at their respective locations where the panels are cut. The staircase work is also taken up using GFRG panels as the waist and landing slabs with reinforcement bars in all the cavities. Shuttering for sunshades is also put in place along with reinforcement bars. Next, the work of casting the first floor slab is taken up. Instead of a conventional solid concrete floor slab, which is typically 100 to 125 mm thick, the GFRG panels are used. They are placed horizontally over the walls in different routes. The ribs typically spanning along the shorter direction. Concrete tie beams connect the panels to the walls at all junctions. Every third cavity in the horizontal GFRG panel is cut open from the top and a reinforcement cage inserted to serve as a concealed beam. Further, a steel welded mesh is placed on top of the entire floor slab and is subsequently embedded in a screed of concrete 50 mm thick. The advantage with this system over conventional concrete slabs is that there is no need for shuttering and the finish at the bottom is excellent, not requiring any plastering. Also, the propping required from below at the time of concreting is minimal. Conduits for electrical work are kept in place before concreting the slab. After completion of the entire concreting in the floor slab, including the balconies and the staircases, the panel erection for the walls in the next floor is taken up and rapidly completed. Let us now go inside the building and look at the finished interiors.